Good evening, dear students. Yes. So, in the last week, we were discussing about the CET model question, right? We were solving the CET model question paper. So, yes, today we are going to continue with the same. So, I think we have solved some 18 question in the last week. Okay. So, let us continue. So, so this is the questions. Okay. So we are going to see here some of the questions are from the deleted syllabus. Okay. So those questions we are not going to do. Okay. So the questions only which are included in your syllabus. So that only we are going to solve. Okay. Last week we have started with the model question paper solving. So this is a second class. Okay, fine. So whoever has missed the first class, you can attend the class there. Okay, you can watch the class there. Okay, yes, fine. So let us start. So let us start from the 19th question. Meso compounds do not show optical activity because one, they do not contain chiral carbon atoms. Two, they have non-superimposable mirror images. Three, they contain plane of symmetry. Fourth, they do not contain plane of symmetry. Meso compounds do not show optical activity because. Yes. Why meso compounds do not show optical activity? What are meso compounds, first of all? So this is a question from the chapter haloalkanes and haloarenes, right? So their stereoisomerism is there, right? We have studied about inversion configuration, retention of configuration. Then we are having their racemization, right? Racemic mixture. What is this enantiomers, right? What are meso compounds? So these things we have discussed. What is optical activity, right? What is dextrorotation, what is levorotation. So these things we have discussed there. So can you tell me why meso compounds, they do not show optical activity? First of all, what are these meso compounds? So meso compounds, they are optically inactive. Why? What is the reason? What are meso compounds? They are the stereoisomers. Okay, they are the type of stereoisomers with two or more chiral centers, right? We know what are chiral centers, right? A chiral carbon having four different groups or four different atoms, it is called as a chiral carbon, right? So, but these meso compounds, okay, they are stereoisomers. They are having two or more chiral centers, but they do not show any optical activity. Okay, and these are called as achiral compounds. Okay, these are achiral compounds, but with chiral centers. Okay, now why they do not show this optical activity? Why they do not show optical activity? What is the reason? They do not contain chiral carbon atoms? No. Okay, by definition, it contains chiral carbon atom. So, first option is discarded. They have non-superimposable mirror images. Non-superimposable mirror images, they are present in enantiomers, right? Enantiomers are those stereoisomers which have non-superimposable mirror image. So, this is also discarded. Third one, they contain plane of symmetry. Yes, yes. So option number third one, right? Because it contains what? It contains plane of symmetry. Okay, so meso compound, they do not show optical activity. Why? What is the reason? Because they contain plane of symmetry. Okay, so this is the reason why okay. So if I give you example of a meso compound, okay, if I give you example of a meso compound, so suppose like CHCl, okay, and this is CH or H. I can take here CH3 if I want, CH3, and your one Cl. So you can see they are having two chiral center, right? So 1, 2, 3, and 4, okay, different group attached to this chiral carbon. And then if I consider this carbon, so 1, 2, 3, and 4. So two chiral centers are present. But okay, so mesocompounds, okay, but you can see there is a plane of symmetry. If I put a mirror image here, if I put a mirror here, so half of this molecule will cancel the other half, right? So these are called as a mesocompounds. So mesocompounds, they are stereoisomers which are containing two or more chiral center, okay? But because of the plane of symmetry, they do not show optical activity. Okay, so option number three, they contain plane of symmetry because of which they do not show optical activity. Okay, so let us go for the next question. I hope this is clear. Yes. Okay. When formic acid is heated with concentrated H2SO4, the gas evolved is. Yes, when formic acid, okay, is heated with concentrated H2SO4, that is your sulfuric acid. So which is the gas released? Formic acid is this, okay. Formic acid, when you react it with concentrated H2SO4, so which gases evolved, they have asked. Yes. Anybody? So the answer is option number 2. Okay, so these are the options: only carbon dioxide, only carbon monoxide. Third one, a mixture of carbon dioxide and carbon monoxide, a mixture of sulfur dioxide and carbon dioxide. So when you heat formic acid, okay, with sulfuric, so carbon monoxide and water vapors are evolved. Okay, so carbon monoxide and water vapors are evolved. So if I write the reaction, formic acid reacted with your concentrated H2SO4, I'm going to get carbon monoxide plus water, okay, water vapors in the form of water vapors. So option number 2, option number 2 is the answer. Let us go for the next one. Temperature coefficient of a reaction is 2 when temperature is increased from 30 degree to 90 degree Celsius. The rate of reaction is increased by. Temperature coefficient of a reaction is 2. When temperature is increased from 30 degrees Celsius to 90 degrees Celsius, the rate of reaction is increased by 1 60 times, 2 64 times, 3 150 times, and 4 400 times. Yes, how you are going to answer this? Try to answer. You can use the chat box for answering. Yes, what will be the answer? Yes, students, you can use the chat box for answering. Temperature coefficient of a reaction is 2. When temperature increased from 30 degree to 90 degree, the rate of reaction is increased by. So what all is given? Temperature coefficient is given. Okay, temperature coefficient is given. What is the temperature coefficient? Temperature coefficient is 2. Okay, and what is given again? The change in temperature, right? The change in temperature, that is 90 minus 30. Okay, 90 minus 30. What is the change in temperature? 90. So from 30, the temperature has increased to 90. So there is a change in temperature, that is 90 minus 30 degrees Celsius, that is 60 degrees Celsius. Okay. So what is this temperature coefficient? What do you mean by this temperature coefficient? Temperature coefficient, it is a ratio of your rate constants. Okay. When you are increasing the temperature by every 10 degree rise in temperature. Okay. So rate constant, so it is a ratio of the rate constant when the temperature it is increasing by or it is increased by 10 degree. This okay. Now here the coefficient is 2. Okay, so 2 into so here so 60. So how much temperature has been increased? 60 degrees. 60 degree means it is 6 times. Right? 60 degree means coefficient means what? Temperature coefficient, rate constant when the temperature is increased by 10 degree. Right? So now the temperature has increased by 6 times. Right? So coefficient is 2. So 2 raised to 6 is how much? 2 raised to 6 is how much? It is 64 times. So the temperature coefficient, okay, when the temperature is increased from 30 to 90 degree, the rate reaction is increased by 64 times. Okay, it is by 64 times. So option number 2. Option number 2. Yes, Sri Varuni has answered it. Okay, very good. So 64 times the rate of the reaction is increased. Okay, fine. I hope you have got it. Yes, fine. Let us go for the next one. Conversion of benzene to acetophenone can be brought by. Conversion of benzene to acetophenone can be brought by one, your Woods reaction. Second one, Woods fatigue reaction. Third one, Friedel-Crafts alkylation. And fourth one, Friedel-Crafts acylation. So conversion of benzene to acetophenone. How it can be brought up? How it can be brought by? Yes. So the answer is fourth one. Okay, the answer is fourth one. Friedel-Crafts acylation. So if I have a benzene, if I do acylation, acylation means what? I'm going to take acetyl chloride. Okay, I'm going to take acetyl chloride in the presence of anhydrous AlCl3. So what will happen? Your acetyl group, okay, your acetyl group will attack your your benzene will attack your, because benzene is nucleophilic in nature. So benzene will attack your carbonyl carbon. Okay, and what I am going to get? I am going to get a acetophenone. Right. So I am going to get what? Acetophenone plus HCl. Okay, plus HCl. So this is my, so by what method I have got acetophenone? By Friedel-Crafts acylation. Okay, by Friedel-Crafts acylation. I hope you have got it. Yes. Is it clear? Is it clear? Let us move for the next question. Okay, fine. Excess of PCl5 reacts with concentrated H2SO4 giving. So this is from your P block elements. Okay, so leave this question. Next question, an example of a neutral buffer is. An example for a neutral buffer is. What is a buffer? What is a buffer? This will come from equilibrium, PU1. Okay, this is a question from PU1. What is a buffer? Buffer solutions. Okay, remember buffer solutions. So what are these buffer solutions? Buffer solutions, what they do, they resist the change in the pH. Okay, when you add small amount of your strong acid or base. Okay, when you add small amount of your strong acid or base, what they will do, they will change the, they will try to resist. Okay, they will try to resist the changes in the pH. Okay, they will try to resist. So what is a neutral buffer? Neutral buffer. So neutral buffer, you get this neutral buffer when you mix a weak acid, okay, weak acid and a weak base. So when you mix a weak acid and a weak base, you are going to get a neutral buffer. So option number 1, ammonium hydroxide and ammonium chloride. Second one, acetic acid and sodium acetate. Third one, acetic acid and ammonium hydroxide. Fourth one, citric acid and sodium citrate. Yes, what is the answer? What is the answer? So the answer is option number 3, acetic acid and sodium hydroxide. Okay, so acetic acid is a weak acid, right? Acetic acid is a weak acid. So acetic acid and ammonium hydroxide. So this is your what neutral buffer. Okay, ammonium hydroxide. Okay, let us go for the next one. Least energetic conformation of cyclohexane is. So least energetic conformation of cyclohexane is first one chain conformation, second one boat conformation, third one cis conformation, and fourth one EZ conformation. So this is a cyclohexane. Okay. So in which position this is what you say it is least energetic cyclohexane. So there are both like you can convert the cyclohexane in the chair form. Okay, this is chair conformation, not chain. Chair conformation. So then you can change it to boat form, cis form, okay, and EZ form. So which is the least energetic? Yes. So the answer is chair. Okay, chair conformation is the least energetic. Okay, chair conformation is the least energetic. So in this chair form, it is less energetic. The reason, what is the reason? Due to less angle strain. Okay, due to less angle strain. Okay, and there is a legs diaxial interaction. Okay, so chair conformation is least energetic. But it is least energetic conformation, but it is the most stable. Okay, it is the most stable. It is least energetic, but most stable because the angle strain is very less. Okay, angle strain is very less. So option number 1 is the correct answer. So chain conformation is the least energetic and most stable conformation of zinc. Okay, fine. So which of the following is employed in the flash tubes in photograph? Okay, again, this is from P block. Okay. Okay, go for the 27th question. Conjugate base of H2PO4 minus is. Conjugate base of H2PO4 minus is. What is a conjugate base? What is a conjugate base? You need to know this first, okay? Before answering, you need to know what is a conjugate base. So when your acid, okay, when you have an acid, suppose I will take a HCl acid, okay, hydrochloric acid. So acid, what will happen? It will lose its proton, right? It will lose its proton. So, conjugate base, how a conjugate base is formed when an acid will lose a proton. Okay. Now H2PO4. So H2PO4, 4 minus, PO4 minus. Right, just a second. So H2 PO4 minus. Okay. So this, what it does, it acts as both, okay, acid and a base. So H2PO4 minus, what it does, it acts as both. Okay, acts as both your acid as well as a base. So when it acts as an acid, what it will do, it releases proton. Okay, it will release proton and it forms what? It releases proton and it forms HPO4 minus 2. Okay, and when it acts as a base, okay, when it acts as a base, what it will do, it will accept a proton. Okay, it will accept a proton and it will become H3PO4. Okay, orthophosphoric acid. Right, now conjugate base. So conjugate base of this is what? HPO4 minus 2, because What is the conjugate base? It will, what it will do, conjugate base, it will accept a, it will, yes, it will release a proton, right? So it will take a proton. So acid, it will lose a proton. So it will form HPO4 2 minus. So HPO4 HPO4 minus. Okay. Okay, fine. Let us go for the next one. 28th question. An alkyl bromide X reacts with sodium in ether to form 4,5-diethyl octane. The compound X is. An alkyl bromide X reacts with sodium in ether to form 4,5-diethyl octane. The compound X is. Yes, how you are going to answer this? So you have a alkyl bromide. Okay, this alkyl bromide, it is reacting with what? It is reacting with sodium. Okay, it is reacting with your sodium and to form 2,4,5-diethyl octane. Okay, so what is the compound X they have asked? So 4,5-diethyl octane. Okay, so if I take the starting compound, okay, so if I take alkyl, so you know that alkyl halides, they react with sodium, right? In the presence of what? Dry ether, and they produce what? They produce, so this is a Woods reaction, right? So now here if I take, so these are the four options. Okay, so if I take CH3, CH2, CH2, CHBr, CH2, CH3. Okay, now here 4,5-diethyl octane. Octane means how many carbon atoms? 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So at 4 and 5 position, 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So what I have? 4, 5 diethyl. Okay. So, okay, so if I break this compound here, so if I break this compound here, okay, if I break this compound here at, uh, okay, it is a symmetrical compound, right? So 8 carbons, so 1, 2, 3, 4, 5, 6, 7, 8, right? So 1, 2, 3, 4, 5, 6, 7, and 8. So at fourth and 5 position, I have got ethyl groups, right? So at 4, what I'll do, I'll cut it from here. So what is this compound? Just see 1, 2, 3, 4, right? So if I put here at CH, if I put a Br, okay, if I introduce a Br, so what I'm going to, so what will happen here? So this is the final product which I am going to get, right? So our reactant will be option number fourth one. CH3, CH2 twice, CHBr and CH2, CH3. So I need 2 moles of this, okay, alkyl bromide, and I'm going to react it with sodium. So I'll show you the reaction. Okay, so if I take CH3, CH2, CH2, CHBr and C2H5 plus plus 2Na. Okay, then CH3, CH2, CH2, CHBr, and C2H5. So, in the presence of what? In the presence of dry ether. So, this is a Woods reaction. Remember, right? So, what will be our byproduct? Na, let me write this Br here so it will be easy for you to understand. So plus 2 NaBr, okay, and this will get attached here. So CH3, CH2, CH2, CH, okay, C2H5, and so this will attach here. So CH, C2H5, okay, CH2, CH2, and CH3. So this is our octane, okay, 4,5 diethyl octane. So our reactant is alkyl bromide is this. So option number 4 is the answer. I hope you have got it. Yes, is it clear? Simple, okay, simple Woods reaction. So you need to, so if they have given the product, you have to cut the product into two reactants, because we know that in Woods reaction we require 2 moles of alkyl halide, right? 2 moles of alkyl halide will react with the sodium in the presence of ether, right? And I'm going to get a alkane, higher alkane, right? Fine. Let us go for the next one. Which one of the following will show highest magnetic moment? Which of the following will show the highest magnetic moment? First one Fe plus 2, second one Co plus 2, third one Cr plus 3, and fourth one Ni plus 2. Yes, which will show the highest magnetic moment. How do we calculate magnetic moment first of all? Magnetic moment, how do you calculate magnetic moment? How do you calculate magnetic moment, students? Mu is equals to root of n into n plus 2 both magnetum, right? So Fe is 26, right? So argon 18, 3D, 6, 4s2, then cobalt, then chromium. Chromium is plus 3, right? So it is chromium. So argon 18, 4s2, and 3D 5, right? Then nickel is 28, so it will be argon 18. Chromium is 3D5. Okay, I'll write directly, okay, in plus 3 state only. So let us write directly in the plus 3 state. So Fe, so let me write from Fe first. So Fe is what? Fe is in plus 2. So plus 2 means 2 electrons are lost. So it will be argon 18. Okay, argon 18 and 3D6. Okay, 3D6. So if I distribute the electrons, okay, if I distribute the electrons, so first the electrons are singly, and then pairing will take place. So 4 unpaired electrons are there. So 4 unpaired electrons, okay, unpaired electrons. Then in cobalt, okay, cobalt plus 2, cobalt plus 2, okay. So in cobalt plus 2, so it is 3D7. Okay, it is 3D7. So put the number of electrons. So 1, 2, 3, 4, 5, 6, and 7. So there are 3 unpaired electrons. 3 unpaired electrons. Then Cr plus 3. In Cr plus 3, the number of unpaired electrons. Okay, after you write the electronic configuration, it is 3D5. Okay, so there are 5 unpaired electrons. 1, 2, 3, 4. Then nickel, nickel in plus 2 state, 3D8. Okay, nickel in plus 2 is 3D8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 unpaired electrons. So if you put the values, okay, if you put the values, so what you have to do, n is nothing but n is the number of unpaired electrons. So put the number of unpaired electrons here and you are going to get the answer. So our answer for this particular question you have to get is option number 1. Okay, Fe. Fe will get the what Fe will be your answer. Okay, so Fe is the answer. So the highest magnetic moment. So by putting the value in this particular n into n plus 2, okay, Bohr magnetum. So n is equals to number of unpaired electron. Okay, so put the value and you're going to get the answer as option number 1. Okay, fine. Let us go for the next one. The EMF of a galvanic cell constituted with the electrode Zn plus 2 bar Zn minus 0.76 volts and Fe plus 2 bar Fe minus 0.41 volts E. So you have to calculate the EMF of a galvanic cell constituted with the electrode Zn plus 2 bar Zn minus 0.76 volts and Fe plus 2 bar Fe minus 0.41 volts is. So how to calculate the EMF? Yes, students, how to calculate the EMF? How we are going to calculate the EMF here? What will be the answer? So 4 options are given. How you are going to answer? We know that E naught of the cell is calculated as what? E of cathode minus E of anode. Remember? So this is the question from electrochemistry. E naught of cell is equals to E of cathode minus E of anode. So E of cathode is what? On the right hand side. That is minus 0.41. Minus of E of anode will be on left hand side. So that is minus of minus 0.76 volts. So this is minus 0.41 plus 0.76. So the answer will be in plus. So plus, see what answer you are going to get. So plus 0.35 volts. Option number 3. Okay. Option number 3. So I have got option number 3 as the answer. Are you getting the same? Okay. Let us go for the next one. Yes. Okay. Shri Varuni has also got it. So which of the following pairs are correctly matched? Rx plus AgOH. So reactants are given and products are given. So you have to tell which is the correctly matched pair. Okay, reactants and products. So which is the correctly matched pair you have to tell. So see. Which is the answer? Try to answer. So Rx plus AgOH, aqueous giving you RH. Rx plus AgCN, alcoholic AgCN giving you RNC. Rx plus KCN giving you RNC. Fourth one, Rx plus Na giving you RR. So this is the Woods reaction. Okay. You're going to get a higher alkene. So this is correct. When KCN reacts with Rx, you are going to get cyanides. Rx, you're going to get isocyanate. So 2 and 4th is correct. Okay. And Rx, when it reacts with AgOH, Rx, when it reacts with AgOH, what you're going to get? Rx, when it reacts with AgOH, you're going to get ROH. Okay, and plus AgX. So RH will not be formed. So this is also wrong. So option number 4th one is right. Second and 4th is the correct products. So 4th one. Yes, yes, Sri Varuni has answered. Okay. So 4th one. Okay. So when Rx reacts with your, that is your alkyl halides react with your AgCN, you are going to get isocyanates. When your alkyl halides react with potassium cyanide, you are going to get cyanides. Okay, not isocyanide. So this is also wrong. So your second and fourth is the correct answer. Okay. Correct. Okay. Let us go for the next one. In a transition series with increase in atomic number, the paramagnetism, first one increases gradually, second one decreases gradually, third one first increases to a maximum and then decreases, fourth one first decreases to a minimum and then increases. In the transition series, what will happen? In the transition series with increase in atomic number, what will happen to paramagnetism? Yes, students. What is the answer? You can answer. Let us see the answer. So what will happen when you are going in the transition series? So paramagnetism, how do you define paramagnetism? Depends on the number of unpaired electrons. Paramagnetism depends upon the number of unpaired electrons, right? So now in a transition series, so paramagnetism first it gradually increases and then it decreases. Okay, with increase in atomic number. With increase in atomic number, further it decreases. So option number third one is the correct answer. Okay. Third one is the correct answer. Okay. Let us go for the next one. Identify a species which is not a Bronsted acid but a Lewis acid. Identify the species which is not a Bronsted acid but a Lewis acid. What is a Bronsted acid? So you need to know what is a Bronsted acid and you need to know what is a Lewis acid. What is a Bronsted acid, students? What is a Bronsted acid? Bronsted acid means what? It donates proton. Okay, it donates a proton. Okay, and your Lewis acid means what? It accepts an electron pair. Okay, it accepts an electron pair. Now you have to identify a species which is not a Bronsted acid but a Lewis acid, means it should accept a pair of electron pair. Yes. Which is the answer? First one. Okay, boron trifluoride. So boron trifluoride is the answer. So boron trifluoride is not a Bronsted acid but a Lewis acid. Okay, your boron trifluoride. It is not a Bronsted acid. It will not donate a proton. Do you see any proton in BF3? No. But what it will do? It will accept a pair of electron. Okay, it will accept a pair of electrons. So boron trifluoride. Next question. The compound formed when calcium acetate and calcium formate is dry distilled. First one acetone, second one acetaldehyde, third one benzaldehyde, fourth one acetophenol. Yes. So when calcium acetate, okay. So CH3 C double bond O, CH3 C double bond O. Okay, so this is a calcium acetate. Okay, this is a calcium acetate is reacted with your calcium formate. Okay, calcium formate. Okay, and if you heat it, if you do a dry distill, what I'm going to get? See, I have written the, so CH3, CH3, CHO 2 times, right? Plus 2CaCO3. So what I'm going to get? I'm going to get a acetaldehyde. Option number 2. I'm going to get a acetaldehyde. So when calcium acetate, so this is our calcium acetate. Okay, I have heated with what? I have heated with the calcium formate. Okay, so just I have written. So like this is the calcium formate. Okay, COH. Okay, calcium formate H. So I'm going to get what? Acetaldehyde and calcium carbonate. Okay, so option number 2. Okay, let us go for the next one. D2sp3 hybridization of the atomic orbitals gives. So when you have a D2sp3, when you have D2sp3 hybridization of the atomic orbitals gives. So what type of hybridization does D2sp3 show? 5 are involved. Okay, whenever you have a 5 D2sp3, yes, students. First one square planar structure, second one triangular structure, third one tetrahedral, fourth one octahedral. Yes, yes, answer. When you have D2sp3, you are going to have a octahedral. Okay, I'm going to have a octahedral structure. So octahedral means what? 4 ligands at the 4 corners of the square and 2, okay, at the above and below the plane. Okay, so this is the octahedral structure. So option number 4 one. D2sp3 hybridization of the atomic orbitals will give you octahedral structure. Okay, so the pH of 10 raised to minus 8 molar HCl solution is, the pH of 10 raised to minus 8 molar HCl solution is, first one 8, 2, second one 6.9586, third one more than 8, fourth one slightly more than 7. Yes, pH of 10 raised to minus 8 molar HCl solution. pH is what? Negative log of H plus ion concentration. So minus log of 10 raised to minus 8 is how much? Find out. Find out. So it is slightly, so it is acidic pH. Okay, so it will be option number 2. Yes, 6.95. Right. So when it is slightly more than 7, it will be means what? It will come into basic only. More than 8, basic. So this will be neutral. Slightly more than means it will come in neutral. Okay. More than 8, it is what? Basic in nature. This is also basic in nature. When you have 1 to 7, okay, remember that. Okay, 1 to 7 is acidic pH. So that also you can uh, put that. Okay, you can use your head like this. Okay, so less than 7 is acidic pH. So 6.9. Okay, it is less, slightly less than your 7. So, or if you solve also, if you take minus log of 10 raised to minus 8, if you solve this also, you are going to get 6.95. Okay, so option number 2 is the answer. Okay. Next one, which of the following is strongly acidic? A, phenol, two, orthocresol, third one, para-nitrophenol, and fourth one, paracresol. Which of the following is strongly acidic? Phenol, orthocresol, para-nitrophenol, paracresol. Yes. What is the answer? Remember, we have solved this in, okay, Shivaruni has answered as 1. Phenol. Phenol is strongly acidic. I'll write the structures. Phenol is OH, orthocresol, para-nitrophenol, and paracresol. Third one, yes, para-nitrophenol. Yes, option number third one is the correct answer. Para-nitrophenol. Why? In phenol, your OH group, okay, it is weakly acidic, okay, because due to resonance stabilization of the phenoxide ion. When you see your para-nitrophenol, okay, para-nitrophenol is what? It is a strong electron withdrawing group, right? It is a strong electron withdrawing group. So what it will do? It will, what it will do when it is withdrawing the electron, right? So in turn, what will happen? The electron density will be less and it will be what? It will be more acidic in nature. And when you have electron donating group, what will happen to the electron density of the benzene ring? It will increase and therefore the electron, therefore the this okay compound, your para cresol will be less acidic in nature as compared to your para-nitrophenol. So para-nitrophenol, because it is having what? It is an electron withdrawing group. Okay, it will withdraw the electron towards itself, and it has a strong what you say inductive effect, right? And it is showing the mesomeric effect also. And because of that, it can stabilize your resonance ion also. Okay, and because of that, so rest among the all, this will be more or highly acidic in nature. So option number uh, 3. Option number 3 is the answer. Okay, fine. Let us go for the next one. A group of atoms that function as a ligand only when it is a small molecule, it has an unshared electron pair. Third one, it is a negatively charged ion, it is positively charged ion. A group of atoms can function as a ligand only when. So when a group of atom can act as a ligand, so what is a ligand? Ligand, yes, a ligand should have at least one lone pair of electrons, okay, so that it can donate it to central metal ion, okay, so that it can form a coordinate bond. So it is option number 2. Okay, it is option number 2. So a group of atoms can only function as a ligand when it can have an unshared electron pair. Okay, so that it can donate it to central metal atom. Okay, fine. Next one, which of the following is not a colligative property? First one, elevation in boiling point. Second one, depression in freezing point. Third one, osmotic pressure. And fourth one is lowering of vapor pressure. Yes, which is not a colligative property. It is lowering of vapor pressure. Okay. Elevation in boiling point, depression in freezing point, osmotic pressure, and relative lowering of vapor pressure are the colligative property. Lowering of vapor pressure is not a colligative property. Okay. So yes, option number fourth one, not third one. Osmotic pressure is a colligative property. Osmotic pressure is also a colligative property. Lowering of vapor pressure, they have said. The term is relative lowering. Okay, so relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. These are the four colligative property and not lowering of vapor pressure. So fourth is the answer. Okay, fourth one. Understood? Fourth one. Okay, fourth is not a colligative property. Lowering of vapor pressure. Fine. Then acetone and propanol are acetone and propanol. What are these acetone and propanol? What are these? Can anybody tell? First one functional isomers, second one position isomers, third one geometrical isomers, and fourth one optical isomers. I have written the structures. This is a acetone. This is a propanol. Propanol. Propanol means what? Propanol is a aldehyde. Al is there, right? Al, not all. Propanol. So what is it is? Can anybody tell me what is propanol and acetone? You can see the structures I've written and you can see the formula also. This is the formula. Both is having the same formula, only what is different? Okay, Ankita has answered as Anita. Anita has answered as A. Yes, very good. It is a functional isomer, right? You can see there is a change in the functional group. Okay, so this is a ketone, this is a aldehyde, right? So molecular formula is the same. Formula is the same. Okay, it is the same, only change in the functional group. So these are the functional isomers. Okay. So go for the 42 question. 3 grams of urea is dissolved in 45 grams of water. 3 grams of urea is dissolved in 45 grams of water. The relative lowering in vapor pressure is. How we are going to solve this, students? Solve this simple question. We need to use the Rawls law. Okay. Rawls law of relative lowering of vapor pressure. Okay. We know that according to Rawls law, the relative lowering of vapor pressure is equal to the mole fraction of the solute, right? So calculate the moles of urea. First calculate the moles of urea. So 3 grams by 60 grams. Urea is 60 grams. Okay. So this will be 0.05 moles. So the number of moles is given mass upon the molecular weight, right? Number of moles is given weight upon molecular mass of the urea, that is 60. So it will be 0.05 moles. Okay. Then calculate the moles of water. Moles of water. N is equals to water 45 gram. Okay. Water is given gram is 45 and the molecular weight of water is 18 gram, right? 18 gram per mole. So what will be the answer? So 45 by 18, it will be 2.5 moles. So we have got the number of moles. Now calculate the mole fraction. Okay, calculate the mole fraction. Calculate the mole fraction. Calculate the mole fraction. So number of moles of A by Na plus B. So number of moles of urea. Okay, how we are going to calculate number of moles of urea by total moles of urea plus water. Okay, so number of moles of urea is how much? It is 0.05 upon total moles is 0.05 plus 2.5. Calculate how much you are going to get C. Calculate how much you are going to get C. So what answer they have got? Let us see. Find out. Okay. So how much you have got? 0.05 plus 2.5. 0.05 plus 2.5 is 2.55 divided by 0.05. So calculate. So 0.05 divided by 2.55. So 0.02. Are you getting the same? So option number 3. Option number 3. Yes. Yes, Shivaruni. 0.019 is nothing but 0.2, right? So yes, Anita has also answered it correct. Yes, very good. Okay, so option number 3. Okay, don't do, if it is 0.019, don't do it as 4, because whenever 5 and above digits, okay, you know that 0.016 or 0.017 is nothing but it will be equal to 0.02. Okay, if the answers are so much relative, then you have to consider these next unit also, and you have to make it as this. Okay, so somewhere, but you're going to get it as 0.02 only. So option number 3. Okay, fine. Next question. The reagent used to distinguish between acetaldehyde and benzaldehyde is. The reagent used to distinguish between acetaldehyde and benzaldehyde is. First one, Tollens reagent. Second one, Fehling solution. Third one, 2,4-dinitrobenzene, benzyl hydrazine, phenyl hydrazine, 2,4-dinitrophenyl hydrazine, and fourth one, semicarbazide. Yes, Anita and Shivaruni has answered as 1. The reagent used to distinguish acetaldehyde and benzaldehyde is. The reagent used to distinguish between acetaldehyde and benzaldehyde is. So acetaldehyde, okay, and benzaldehyde. So one is a aliphatic aldehyde, another is a aromatic aldehyde. So when you use this, okay, how to distinguish, they have asked, how to differentiate. So if you take acetaldehyde and benzaldehyde, okay, both with the help of Tollens reagent, they will give you silver mirror test. Both will answer the silver mirror test. But when you test it with Fehling solution, okay, Fehling solution, your acetaldehyde will give the reaction, but your benzaldehyde will not react. Why? Because it does not have any alpha carbon. Okay, so the answer is second one, Fehling solution. Remember that. Okay, so they have asked how to distinguish acetaldehyde and benzaldehyde. Both will answer the Tollens reagent. They will both will give the silver test. But how to know whether which is a aliphatic and which is a aromatic? Okay, now aliphatic your this what aldehydes, they will answer your Fehling solution. But not aromatic, because in aromatic aldehydes they do not have a alpha carbon. Okay, there is no alpha hydrogen, sorry, not carbon, alpha hydrogen is not present. So answer is option number 2. Understood? Fehling solution. So to distinguish between the aromatic and aliphatic aldehyde, so Fehling solution. Okay, because aliphatic aldehydes, they will answer because they are having a alpha carbon. So this is the alpha hydrogen, not alpha carbon, alpha hydrogen. So this is alpha hydrogen present. But in case of your benzaldehyde, okay, where is alpha hydrogen? Where is alpha hydrogen? No, alpha hydrogen is not present, right? So, so this is the answer. So second one. Okay, fine. Is it clear up to here? Okay, so these were some of the questions from the model question paper. Okay, so I hope you have understood. So like this only the questions will be. Okay, so what you need to do is, so you have to practice more this. So what you can do, you can practice some repeatedly asked questions. Okay, you can Okay, you can solve some 4-5 years question papers, okay, so that it will be helpful for you. Okay, then you will get the idea, okay, how what type of questions are asked. So try to solve some 4 to 5 years question paper, okay, CET question paper, okay. So these are some of the questions. Fine. So any doubts up to here? No. Okay, fine. So I shall end the session here. Okay. We will meet in the next week. Thank you.